Hi folks, and welcome to Section 6, R Visualizations, a simple route to sophisticated graphics. In Module 1, we'll talk about generating data for Monte Carlo analysis using R. The R statistical language plays two distinct roles in Power BI. We can use R to import data. This can be valuable because R has a very rich toolbox that allows us to manipulate imported data to get it into the format that we find most useful. The second way to use R is to make use of the vast array of special plots and charts that R provides to supplement the built-in visualizations in Power BI. We're going to start with a look at Monte Carlo analysis for two reasons. One is that very important and valuable technique, particularly in the world of finance. But secondly, it also highlights some of the advantages to using R to generate random data. Since April 2019, Python has become an official part of the production release of Power BI. And so you can always use Python as an alternative if you prefer it to R. However, since R has been part of Power BI much longer, there are a great many more blogs and resources that you can draw upon when you're mastering your R skills. We'll start by going to the Get Data choice. We'll go to More, pick Other, just to make the list a little bit shorter, and there is our script. I can choose Connect. Once I choose Connect, I'll get a dialog box that will allow me to enter an R script. Now, I won't describe the R script just yet. The main thing I want to call your attention to right now is that this is a very, very poor editing environment. There's no highlighting of keywords. There is no debugging facility. If you make a mistake, the error handling and reporting is going to be very poor. This is simply not acceptable. We'll come back in a little while and see a much better way of integrating R script into Power BI. But for the time being, I'll simply click OK. I'll pick linear data, hit load. And now we have a table called linear data. We'll come back to this choice of term in just a moment. Right now, we'll take it on faith. To confirm that it works the way we expect, we'll add on a scatter plot, and we'll put X along the X-axis, and it's no big shock that we'll put Y along the Y-axis. We'll need to tell R not to aggregate X and Y, so we'll pick Don't Summarize for X, and we'll pick Don't Summarize for Y. The dots in our scatter plot are a tad on the large side, but that's an easy thing to fix by going to Shapes and simply adjusting the size. We'll make them a little smaller to get a feel for the distribution of the data. The distribution of the data, of course, is there's a hypothetical line, and the errors around that line are normally distributed. So far, so good. But what if we want to edit our R code? We could do that by going to the Data tab and then picking Edit Queries. In the Power Query Editor, we can go to Advanced Editor, and what we see is a little bit horrifying. The entire R code appears as one big, long, incomprehensible string in Power BI. Once again, this is simply an illustration of the fact that Power BI's tools for editing are simply not satisfactory. So let's click Cancel. We'll delete linear data. Now we'll go to the R Studio Editor. This is the R code that we ran just a moment ago to generate our test data set. We won't concern ourselves with all the details, except that R has the ability to generate random numbers in a normal distribution and in many other distributions that might be valuable to us. We could, in fact, generate a copula if we needed it for our financial analysis. The most important thing right now is to appreciate the fact that the object called a data frame in R is very analogous to a table in Power BI. In fact, if our R script creates a data frame, it will automatically be imported as a table into our Power BI data model. In this case, I called the data linear data, but the name is completely irrelevant. I could just as easily have called the data Fred. Now I can run this program code in the RStudio environment, and if I wanted, I could test by drawing a plot and see that the code seems to be working fine. Now, as we saw a moment ago, we could copy and paste this code into RStudio, but I think there is, in fact, a better way. So let's go back to Power BI. We'll go to Get Data, More, Other, RScript. We'll connect. And now, instead of pasting in the entire script, what we will do is paste in a fully qualified path to a file containing that script. That will be the argument to the source function, an R function that simply reads an external script and executes it. In this way, not only is it easier for us to develop the script, but at some future date, if we want to modify that script, it's far easier to open up that file in the RStudio and edit it than it would be to go into the Power Query Editor and try to edit the R script there. So we'll go ahead and click OK. And notice that the name of the table we're about to create is called Fred. That's just the variable name that we chose for our data frame in the R script. I'll pick Load. And just like before, X and Y appears. Just like before, we can add X to the X-axis and Y to the Y-axis. And we'll have to explain to Power BI that this is a case where we do not want Power BI to summarize the data. And there we have it. R can provide valuable sources of random input for financial analysts who are using Monte Carlo methods in their analysis. But R is also capable of very effective importing of data from sources in the real world. Sometimes it's more convenient than the built-in Power Query.